Hello, in our previous video on mass, weight and density, we were able to define mass, we defined weight and even density, and we worked out a formula for finding the density of a substance. Now in this video, we are going to talk about other areas. First of all, I would like us to begin with the SI unit of density. Now, since I'm talking about the SI unit of density, it is in order that we discuss density in relation to mass and volume. Let's remind ourselves the formula that we wrote last time. We are going to remind ourselves that using the formula triangle. Now, in this formula triangle, we are going to have mass there. We are going to have density here. And remember, I've used the symbol rho. And today I'm going to replace the vertical line with multiplication sign, so that we see mass is equal to density times volume, whereas density is equal to mass over volume, and volume is equal to mass over density. Now, the formula triangle will help you to be able to memorize the formula for density and all this relationship. For instance, if I have density and I have the volume, I can get mass. If I have the mass and I have the volume, I can get density. And if I have mass and density, I can get the volume. Now, in this, we want to actually talk about the SI unit of density. Now, usually, mass is measured in kilogram. It's measured in kilogram, and the symbol for that is kg. Now, volume is measured in meters cube, or basically cubic meter, which is written as meters cubed, like that. Now, if we have a mass of 1 kilogram and a volume of 1 meters cube, then the density rho would be m over v, which is simply equal to 1 kilogram over 1 meters cube, and this gives us 1 kilogram per meters cube, or simply kilogram per meter cube, which is the SI unit for density. Now, there is usually a way to convert kilogram per meters cube to gram per meters cube. Usually, 1000 kilogram per meters cube is equal to 1 gram per centimeters cube. Now, when you look at this at first glance, one may think that this expression is not correct, simply because we are used to thinking about kilogram being larger than grams, and that is true. But in this case, remember, we are working with a ratio, and we must understand how that comes about. Now, to be able to do that, let's start with the grams. 1 gram over 1 centimeters cube. Now, what is that? Now, look at 1 gram. If you convert it to kilogram, you divide it by 1000. That comes to 1 over 1000 kilogram. If you go to the denominator, 1 centimeters, if you want to convert it to a meters cube, you divide it by 10 raised to power 6. Actually, you divide it by 1,000,000. and that will convert all this to meters cube. Now, if you look at this, you can simply do your multiplication. Maybe I should write it down here. You can use your mathematical relations that you know. This will simply mean we are multiplying by 10 raised to power 6, or basically a million. Of course, if you are a physicist or a mathematician, you can tell that this is actually 10 raised to negative 3, and this one is 10 raised to power 6. If we multiply these two indices, we actually add the powers. This will give us 10 raised to 3, which is the same as 1000. And remember, we have now this is in meters cubed. Now, first of all, it's good to remember not to drop the units before the right time. So I'll retain the units here and here. And finally, just to remind us that actually it is telling us that indeed 1 gram per centimeters cube is equal to 1000 kilogram per meters cube. Let's now do a textbook example. We have a question. The mass of 25 centimeters cube of ivory was found to be 0.045 kilogram. Calculate the density of ivory in SI units, giving your answer in kilogram per meters cube. Now, to do this question, we begin by writing our formula. Density is equal to mass over volume. Now, since our mass is 0.45, 0.045 kilogram, 0.045 kilogram, and our volume is 25 centimeters cube, we will have to convert one of them so that we have uniform units that we are supposed to use as we calculate density. And the easiest way here is to convert kilogram to grams, and that we do by multiplying 0.45 by 1000, which leads us to 45 grams over 25 centimeters cube. Now, if you look at it, you will realize that when you divide by 5, you get 5, and you divide this by 5, you get actually 9. Now, 9 divided by 5 will give you 1.8 grams per centimeters cube. Now, we end up with this as the density of ivory. Now, we have been asked to calculate it in SI unit. The SI unit for density, as we have seen before, is given as kilogram per meters cube. And we've said that 1 grams per centimeters cube is simply equal to 1000 kilogram per meters cube. Now that means the density of ivory would be rho is equal to 1.8 times 10, not 10 but times 1000, because we are simply multiplying by 1000 to convert. That gives us 1800 kilogram per meters cube. Another concept that we want to learn here is the concept of density of mixtures. Now, if you have substance A of mass MA and the volume of the substance A is VA, and then we have substance B of mass MB and volume VB, then if A and B are mixed together, then to get the density of the mixture, which is the combined density or the overall density, you simply get the masses together, add them, mass of substance A plus mass of substance B, you divide by the volume of substance A plus the volume of substance B. Now, in other words, we are saying that the density of the mixture is equal to the mass of the mixture over the volume of the mixture. Now, to help us understand what we are talking about, let's solve this question. Now, this reads 1,800 centimeter cube of fresh water of density 1,000 kilogram per meter cube is mixed with 2,200 centimeters cube of seawater of density 1,025 kilogram per meters cube. Calculate the density of the mixture. Now, to solve this, we start by thinking about the formula for density of mixtures. We said that the density of mixtures, if we have the density of substance A, if you want to get the density of a mixture of substance A and substance B together, you write it as density of substance A plus substance B is equal to the mass of substance A plus mass of substance B over volume of substance A plus volume of B. Now, when you look at the question we have here, this question has the following given to us. We have the volume and we have the density, and volume and density. If you look at it carefully, you then realize that we must actually find out what values of masses we're supposed to use. To be able to get the masses, we need to again note that our formula density is equal to mass over volume will be valuable. And therefore, if we are talking of substance A, this would be for substance A all through. And what that means is that mass of substance A is equal to volume density of A times volume of A. Now, in this case, let the fresh water be our substance A. So, we will take mass of A will be therefore 1800 multiplied by the density, which is 1000 kilogram per meters cube, but we must convert it to grams so that we are consistent with our formula, and the result that we are going to get here will be in grams. So we are going to end up with 1800 grams. If we do the same, a similar thing to substance B, we will find that the mass of substance B would be equal to the density of substance B in this case is 1025, and the density and the volume is 2200. Now again, this 1025 divided by 1000, and when we divide that by 1000, we get 1.025 multiplied by 2200 100, and when you multiply those two, you simply end up with 2255 grams. Now, mass of the mixture is therefore 2255 plus 1800, which gives us 4055 grams. Now that we have the mass of the mixture, and we also have the volumes of these two different substances, that is the fresh water and the seawater, let's check the volume of the mixture by adding the two volumes, which were up here. We have 1800, we add to 2200, that gives us 4,000 centimeters cube. Now, when we go back to our formula, you therefore find that the density of the mixture would be given by the mass of the mixture, which is 4055. We divide that by 4,000. That gives us 1.01375, or simply rounded off to 1.014, and that is going to be grams per centimeters cubed, or in the SI units, we just multiply by 1,000, we end up with 1014 kilogram per meters cube.